In this guide, you'll create a 2D game map using Python, place a player on it, and implement movement logic that lets the player move across the grid in all 8 directions. Along the way, you'll gain a solid understanding of grid representation and movement logic, the same systems that power tile-based games, RPGs, and strategy titles, and serve as a foundation for advanced topics like procedural map generation and pathfinding. If you're watching this on YouTube, you can support the channel by purchasing the complete course package on Gumroad, which includes the PDF guide, source code, and organized video collection. It's the same information, just neatly packaged for convenience and offline learning, and every purchase helps make future tutorials possible. If you've already purchased the course, thank you for supporting my work and helping me continue creating free learning resources like this one. Graphically, a 2D map is a grid made up of rows and columns of cells. Programmatically, this can be represented with a 2D list or a list with additional lists inside of it. Each cell represents both an X coordinate, its column, and a Y coordinate, its row. In order to place the player in a specific cell, you'll set the player's X and Y variable equal to that cell's coordinates. A common way to do that is by giving the player both an X and Y variable and setting them to the appropriate integers. Let's say we want to place the player at tile 1, 3. To find the correct cell to place the player in, we'll first find the row that matches the player's Y position. Then we'll find the column inside of that row that matches the player's X position. This is what placing the player in cell 3-2 would look like, cell 4-1, and finally cell 1-3. Moving the player between the cells is as simple as adding or subtracting 1. If the player wants to move north or up from the current cell, you'll subtract 1 from the Y coordinate. It's the opposite when moving south or down from the current cell. You'll add 1 instead. When moving west or left, you'll subtract 1 from the X coordinate. When moving east or right, you'll add 1 to the X coordinate. To move diagonally, you simply adjust both coordinates at the same time. In order to move northwest, you'll subtract both the coordinates by 1. For northeast, you'll subtract 1 from the Y and add 1 to the X. To move southwest, you'll add 1 to the Y and subtract 1 from the X. Finally, to move southeast, you'll add 1 to both coordinates. You don't need to memorize each direction separately, just remember these 2 rules. Rule 1, the Y coordinate controls vertical movement. Decreasing Y moves the player north or up, and increasing Y moves the player south or down. Rule 2, the X coordinate controls horizontal movement. Decreasing X moves the player west or left, increasing X moves the player east or right. Now that you understand how 2D maps work, let's create one and allow the player to move throughout. Open a blank.py file to code in. The first step is to define the map. We'll use the same list representation that was shown in the previous section. You can make the map as large or as small as you want. So at the top here, we're just going to do map equal to an empty list. And then inside of that list, we're going to create another list like so. And then we're going to fill that list with the following. We'll start with 0, 1, 2, 3, 4. Okay? So now we need 4 more of that same sublist. So inside of Notepad, we can just duplicate that line by using Control D, like so. So we'll just do Control D, Control D, Control D, and save. The next step is to display the map. We'll start off with a for loop that iterates through each Y. So underneath our map here, we'll do for Y in map. So this graphic demonstrates what this for loop is doing to our map. Then we'll add another for loop that iterates through each X that's inside of each Y. So inside of that for loop, we'll make another for loop and we'll do for X in Y. Again, here's a graphical representation of what's happening inside of the second for loop using the first Y as an example. Now inside of the second loop, we'll use an F string, which lets us insert the value of X inside of square brackets so that it looks like a tile on the map. Okay, so inside of here, we'll do F quotations, and inside of that, we'll do square brackets. Inside of that, we'll do curly brackets, and then inside of that, we'll do X. Next, we'll display the F string by using the print function. So we're just going to wrap this F string inside of print. So we'll do print parentheses. By default, the print function automatically moves to the next vertical row when printing, but we want the X's in the same Y to be printed on the same row. The first step to achieving this is to use the end keyword argument. So at the end of our print statement here, we'll just do comma, end, equal to quotes with no space in between them. So if you quickly run the code, you'll see that this causes all the x's to be printed on the same row. Now, in order to create multiple rows, we need to call the print function inside of the first loop, but after the second loop. So it'll be down here. And then we'll do print. Okay. All right, so now if you run the code, you'll see that our map is looking more like a traditional 2D map, and it's separated into different rows and columns. Now that we have the map displayed, we can display the player. Underneath the map, we'll create a variable called player_x and another variable called player_y. And then we'll set both of these variables equal to 0. So let's do player_x is equal to 0, and then player_y is equal to 0. In order to display the player on the map, we're going to take the cell that the player is in, and instead of printing the cell number inside of square brackets, we'll print the @ symbol to represent the player inside of square brackets. So underneath the player coordinates and above the first for loop, we need to create another variable called y_index. So let's do that real quick. We'll do y_index is equal to 0. So later on, we're going to compare the x and y that's currently being iterated through in our for loops to the player's coordinates. If they match, we'll draw the @ symbol instead of the tile's number. So with the way our for loops are set up, the x right here is already an integer, which makes it easy to compare it to player_x. But the y is a list instead of an integer, which means it can't be compared to player_y here. So to get around this, we create a y_index to act as a stand-in for the y. So we have the y_index created, so the next step is to update it whenever the y changes. So inside of the first loop, but after the second one, we're going to update it. So we'll just do it right above our second print statement, and we'll do y_index is plus equal to 1. Inside of the for loop and above the print statement, we'll create an if statement that checks if the player is in the current cell. If so, we'll print the @ symbol inside of square brackets. So inside of the for loop and above the print statement, we'll create an if statement that checks if the player is in the current cell. If so, we'll print the @ symbol inside of square brackets. So we'll just do if y_index is equal to player_y, and x is equal to player_x. Then we'll do print, and inside of quotation marks, we'll do square brackets @, and then we'll use our end argument again. So end is equal to quotations with no space. Okay, so if the player isn't in the current cell, we'll use an else statement to print the cell's number instead. So now we'll just go ahead and add an else statement below our if. So we'll do else like that. And so inside of the else, we'll just print the regular cell instead, which we've already done from the previous step. So all we have to do is bring this up and over. Okay. All right, so now if you run your code, you'll see in the top left corner in cell 00 that we have our @ symbol here. So that's where the player is right now. And let's see, if you change it, we'll do, 1, 4, running again. You'll see now the player is in 1, 4. Show you another example. Let's do 3, 2. Run that. And as you can see, the player is over here in cell 3, 2. Okay, so finally we can implement player movement and allow the player to move in all 8 directions on the map. To do this, we'll use a while loop. A while loop runs over and over again as long as its condition is true. And in our case, we'll be using this right here. We'll do while true, which means that the loop will repeat forever until we manually stop it. All right, so this allows the game to continuously update the map and respond to player input. And so actually we'll move this above the y_index. Okay. And we'll make sure that we move this y_index up and over. And now we just have to move the rest of this over also. So all you have to do is highlight this in Notepad++ and hit tab. In order for the player character to move, the player has to give some type of input. And we can use the input statement to get the game to wait for input from the player. So now still inside of our while loop, but at the very end, we'll do command is equal to input. And inside of input, we'll do quotations and we'll do dash, dash, arrow. So the player can type in anything, but we only want the game to react when they type specific commands like N to move north or W to move west or even Q to quit. We can use the if statement to determine what happens next. So the player needs the ability to quit and exit the loop. So we'll check if the player entered the letter Q. If they did, we'll exit the while loop and quit the game by using the break statement. So underneath command, we'll do if command is equal to Q break. Now we can allow the player to move north by checking if they enter the letter N. As you know, moving the player north involves subtracting their current Y position by 1, but if they're at position 0, when they move, the player will move off the map. To prevent the player from moving off the map, we'll only allow north movement if player underscore Y is greater than 0. We combine this with a check for the N command using the else if statement. So underneath our if statement, we'll do else if command is equal to N and player underscore Y is greater than 0. So if both of these are true, we'll do player underscore Y minus equal 1. We have to do something similar for when the player wants to move south, so we'll check if the player has entered the letter S. In order to move the player south, we have to increase their Y position by 1, which again is fine until they reach the other end of the map. Okay, so notice that the Y coordinate for the first row starts at 0. And since there are 5 rows total, the last row ends at a Y coordinate of 4 rather than 5. To make sure that the player doesn't move past the bottom edge, we can check if the player underscore Y is less than the length of the map minus 1 for allowing the move. We'll need another else if statement for this. We'll do else if command is equal to S. So if the player enters the letter S, and if player underscore Y is less than the length of map. So I'll show you real quick. So this is our map variable right here, and all we have to do is count. So 1, 2, 3, 4, 5. So the length is 5, but the index, the final index is 4. And 5 minus 1 is 4. So we'll do length of map 5 minus 1, 4. So if player underscore Y is less than 4. So if both of these statements are true, we'll do player underscore Y plus equal to 1. We'll repeat the process for the west direction while keeping the player from moving off map. So again, we'll do else if command is equal to west and player underscore X is greater than 0. We'll do player underscore X minus equal 1. And yet again, we'll do the same thing for the east direction. So down here, we'll do else if command is equal to E and player underscore X is less than the length of the map, which is 5, minus 1, which will make it 4. So as long as player underscore X is less than 4, we'll do player underscore X plus equal to 1. Now that we have the 4 main directions implemented, we can now add the diagonal directions. So we'll start with northwest. We'll do else if command is equal to NW and player underscore Y is greater than 0 and player underscore X is greater than 0. We'll do player underscore Y minus equal to 1. Then we'll do player underscore X minus equal to 1. Now notice for these diagonal directions that we're literally just taking each part. So northwest is separated into north and west, and we're just combining these two else statements. So we're combining the north else if, and then we're going down here and combining it with the west else if. All right, so for northeast, we'll do else if command is equal to NE and player underscore Y is greater than 0 and player underscore X is less than the length of the map minus 1. We'll do player underscore Y minus equal 1 and then player underscore x plus equal 1. Now, for southwest, we'll do else if command is equal to SW, and player underscore y is less than the length of the map minus 1, and player underscore x is greater than 0. So if both of those statements are true, or if all three of those statements are true, we'll do player underscore y plus equal to 1, and then we'll do player underscore x minus equal to 1. Alright, so finally we have southeast. We'll do else if command is equal to SE, and player underscore y is greater than the length of map minus 1, and then player underscore x is less than the length of the map minus 1. And if all those statements are true, inside we'll do player underscore y plus equal to 1, and then we'll do player underscore x plus equal to 1. Okay? Alrighty, so let's test everything out. So as you can see that we have our player up here in 0, 0 in the top left corner. So I'm going to move south. As you can see, we moved down a bit. Let's move east. We moved over. I'll move east one more time. Now let's go north. Let's go south. Let's go southeast, southwest, northeast, and then northwest. And then we'll move west. So as you can see, we have a 2D map that our player can move on freely. Okay, so congratulations, you built a working 2D map system using Python. You learned how to represent a 2D map with a list, display the map in the console, place a player on the map, and then move the player in all 8 directions using input. And these are the fundamental concepts used in countless grid-based games, and now you understand how they work at their core. Thank you for checking out this guide, and thank you for your time.